Okay, this video is just going to be an introduction to confidence intervals and things that you can say with the confidence intervals and things that you cannot say about the confidence interval. Extremely important material, always is going to show up on an AP exam and your class exams. So the reason we collect data is we usually don't know something about a population. Otherwise, there's no reason to collect it if we know something. And because we don't know something about the population, we are forced to take a sample to use as a proxy or estimate of the population parameter of interest. Now, please remember, when we're talking about the population, we have parameters. When we're talking about a sample, we have statistics, all right? A parameter is a measure of the population. A statistic is a measure of the sample. So if we only have sample, we are never able to say what the exact population mean is. We can say it's close or we believe it's this, but we're only making a claim because we don't have the exact population parameter. Now we can make that claim with a certain level of confidence. And you've seen this in polling for like political candidates. Someone has 43% of the vote, plus or minus 5%. And we call that a specified interval or range. And that range is called a confidence interval. And it's comprised of two components, the estimate and a margin of error. The estimate or best guess for the population mean is the sample mean, and that makes sense. So basically, we're saying the mean equals X bar or X bar equals the mean. That's our best guess, all right? And we would expect that the class average would be best measured by a sample. So the margin of error creates a range below and above the estimate. The range is based on the sample standard deviation of the sample and the confidence level. So here's our formula. X bar, our sample mean, plus or minus the margin of error. Well, this part right here makes up the margin of error. So I'm going to circle that. So that's my margin of error. T star is the number of standard deviations we are from the mean, and it's determined by our confidence level. So this is determined by our confidence level, and it's the number of standard deviations from the mean. S is the standard deviation of the sample, and N is our sample size. This part that I'm about to circle is known as the standard error. Right? So we have the margin of error and the standard error. The standard error does not include how many standard deviations, T standard deviations, whereas the margin of error does. So the margin of error tells us the confidence level. This is really just the standard deviation of X bar, which is S divided by the square root of N. That's what the standard error is. So what is margin of error? Well, the margin of error is, for a given confidence level, the maximum distance a sample statistic may lie from the true population parameter. This is something you've got to know. Word for word, no, but it's the maximum distance we think the sample statistic will lie from the true population parameter. Our estimate, in this case, since we're talking about our mean, is X bar. So X bar estimates the population parameter mu. So our sample mean, our sample X bar is our estimate. The margin of error is the t-score times the standard error. So this is what our margin of error is. S is the standard deviation of the sample, and N is our sample size. Because we only have sample data, we are never able to say what the exact population mean is. In other words, we can't say it with 100% confidence. Well, we can claim it with different levels of confidence, but we're never 100% sure, so we never say what exact is. All right? So here's what we can claim, and you need to know these. We are blank percent. So it could be 95% or 99% or 80%. confident that the true population mean lies within the interval. Notice I'm claiming not a value, I'm just claiming that it will lie within an interval. All right. We can also claim in repeated testing, we expect this method or our method will capture the true population mean this % of the time. I really like this. It's basically saying, hey, in the long run, or if we did this over and over again, our method is so good that it'll capture the true population mean 95% of the time, or 98% of the time, or 75%, depending on how we set or how many standard deviations we go out. Just as important as what we can claim, and by the way, you need to make sure you know these, the things that we cannot claim. We cannot claim 95% of the values lies within interval. And you're like, why can't you claim 95% of the values lies within interval? Well, the interval, first off, might be wrong. Also, we can have a weird distribution and none of the values lie with the interval. For instance, what if we had a distribution that looked like this? Well, our mean is in between, but our values are outside. So we may not have values lying with the interval. So we can't make that claim. So we can't claim that 95% of the values lie within the interval. We cannot claim there's a 95% chance that a randomly selected value will lie within the interval. Once again, the interval may be wrong, or we just may have a weird shaped distribution underneath. 95% of the samples will result in this interval. Matter of fact, that's just saying that every interval would be the same, and no, the intervals can vary substantially. All we're saying is that we're 95% sure that our interval will capture the mean, not that the intervals will be the same, because the intervals can be shifted one from another. So basically, I could have an interval like this. Well, if my true mean were here, I might have an interval that captures it exactly. I might have one that captures it slightly off, because that mean would still be there, or it may be something like this. So it may capture it, but they're not going to be exactly the same. Matter of fact, they're going to vary based on how wide they are. We can't say that 95% probability the true population mean lies within the interval. We never use the word probability. We say confidence, all right? So we're 95% confident the true population mean, but we never say 95% probability. There's a long explanation that's kind of beyond this course. Once again, we can claim 95% confident the true population mean lies within the interval. We can claim 95% of the intervals collected by this method will capture the true population mean. It may not be in the center, but we can claim that it'll capture it. Please note, so once again, I said you need to make sure you know all of that. We are making a claim about the population mean and not the sample mean, all right? There's no need to make a claim about the sample mean. We know what the sample mean is. We calculated it. We calculated the X bar. Matter of fact, we are 100% sure what the X bar is. And not only that, the sample mean will be the center of the confidence interval 100% of the time. Not off to the side, it'll be the exact center. Why? Because our formula for the confidence interval is X bar plus or minus T star S divided by the square root of N. We're saying, oh, X bar is going to be the center every single time. So there's no reason to make a claim about the sample mean. We're making a claim about the population mean. If you switch it, you won't get partial credit. You will get no credit. Please do not make that error. All right. So again, super important page. As we increase the level of confidence, the margin of error or spread increases. So as I increase my margin of error, it gets wider. The interval gets wider. As we increase alpha, the margin of error decreases, or our confidence level decreases. And alpha is the area in the tails. So basically, we'll get to that later. But as we increase alpha, the margin of error decreases. As the sample size increases, the margin of error or spread decreases. So we get narrower as n goes up. You need to make sure you know these. As alpha goes up, we get narrower. As our confidence level goes up, we get wider. And as our sample size goes up, we get wider. We'll spend more time talking about alpha later, but for the time being, this is something you need to memorize. All right, super, super important page of notes. Make sure you know this and know this well. I guarantee there'll be a lot of test questions from here. All right, thank you.